All right. So we briefly talked about this yesterday in the Desmos activity, but when we touched on it was when we were filling that chart out with the always, sometimes, and never. And we said when you're given 3 bits of information, when you have 3 congruent side pairs, are they congruent? And I said it was always. Well, it's always. We know it's always. In fact, we could actually prove that it's always true. Which is why we can have this thing called a postulate, a side-side-side congruence postulate, because we know that if you have 3 pairs of congruent sides, they will always prove that the triangles are congruent. All right. Now, the things that I want to point out on this are, one, the postulate and how we would usually refer to it, side-side-side, SSS. Right. And secondly, our congruence statement now needs to include a reason. Okay, so before we would just have like triangle ABC is congruent to triangle XYZ. And that's great when we're given 6 congruent parts, the angles and the sides. But if we're not, then we have to say why we're able to say they're congruent. And in this diagram up here, we see the 3 pairs of congruent sides. Because of that, we can say the triangles are congruent by SSS. Okay, so if you're going to be saying the triangles are congruent based on less information than all 6 congruent parts, you have to give the reason why. All right. So this is one example here. This is another example, very similar. The one thing I want to point out here is triangles they can be congruent to one another, but they don't have to be the exact same orientation. For instance, these 2 triangles, like there's no way, unfortunately, I think they're on the same diagram. Yeah, there's no way I could take this triangle and slide it and it would like fit exactly on top of this one, but they're still congruent because their dimensions are exactly the same, right? And their angles are. The way these are, there's actually, we could probably put a little line of reflection and we could reflect this over here, all right, to make this second triangle. But that's okay. Reflections are still congruent. Okay, that doesn't change their congruency. But let's see how we would name these 2 triangles in a congruence statement. So we got triangle JKL, JKL. So in this name, it's going in the order of the single to the double side. So in my second name, I've got to go single to double. So FED. By, and we're using our 3 pairs of congruent sides. So that would be our congruence statement for this example. Side, side, side. All right. Side, angle, side, congruence postulate. Side, angle, side. So we talked about this one yesterday as well. I think this is the last one that we talked about. We're given 2 sides that are pairs of sides that are congruent and 1 angle pair that's congruent. And that angle pair is in between the 2 sides, right? It's in between the 2 sides, or that angle is included with the 2 sides. So the term we used a couple of days ago. All right. But we use this, and it's the side angle side congruence postulate. That angle has to be in between the two sides. Okay? It has to be in between. Here's another example using the side angle side congruence postulate. Two right triangles, side AB and side ST are congruent, and then side CA and side RS are congruent. Triangle ABC will be congruent to, all right, let's see how this is going to work. A is the right angle, so I'm going to start with my right angle in the second triangle. The next point is the first side, it goes A to B. So it's that single hash side, so S to T, and leaves us with R for our third. I, side, angle, side. Okay. Two sides, one angle in between. If you guys, if I'm ever like moving too fast, just raise your hand. All right, or people at home, just speak up. All right. Two triangles, are they congruent? If yes, write congruency. Now, sometimes the diagrams will require us to do a little bit of work. And we'll have to use some previous knowledge in order to find another congruent part. For instance, like right now, all I see are two congruent sides. But I know that there's an intersection point with two lines, and there are angles here that will be congruent on opposite sides of this intersection. The vertical angles, okay? We have vertical angles there, which gives us another congruent angle pair, right? And now we can use side angle side. We can, so this does work. So I could write down, now the nice thing is, they're giving us the flexibility and freedom to name this however we want. So I'm going to start with, I'm going to go ACB. So triangle ACB is congruent to triangle, let's see, that went AC, where C is the angle. So single to double. So I gotta go single to double. So DCB. By side angle side. Okay. Now, the naming part is where you just got to be careful. I'd say it's the, and I mentioned this the other day, it's the most common mistake people make is they get the order mixed up with how they name the triangles. We need to make sure that those triangles, every corresponding part matches up. And I forgot to mention this on the first slide, but once we prove that the triangles are congruent, right? Now we can't do this until we prove them, but once we've proven those, we can actually go around and we can mark all these other things. Like all these other things become, like we know them to be congruent, actually. 2, 3, and this side will be, right? So once we know the triangles are congruent, we know that all 6 parts are going to be congruent, right? But we don't know that until we've proven that they are. So you can't just go around and start marking all the congruent parts on it until you've actually determined, are they congruent? Here's one, are the 2 triangles congruent? Let's see. Another one where we got to do a little bit of work. And a shared side is a congruent side. But I don't see any angles that are congruent here. So to me, this looks like not enough information. Okay, even though they do look congruent, right? So in this case, I'd accept an answer like not congruent or not enough with not NLI and EI. Not enough information. Okay. There will be some of these that, and again, we give them to you guys to check your knowledge and make sure that you understand what you're doing. But some of these won't have enough information. And if you don't have enough information, then you can't do it, okay? Or at least you can't prove that they're congruent. They may be congruent, but we can't prove it. Okay, here's another one where you got to use some previous knowledge, do a little bit of work. I see two sides, the single and the double, in both triangles. But, well, this angle is 115. I'm not sure if this one is, but we can figure that out. I'm going to add these two angles. 40 to 25 gives me 65. Since I know that all three have to add to 180, subtract 65 from 180, and I do get 115, which proves these two angles are congruent, which allows us to use side angle side to prove that they are congruent. So and again, I'm skipping over the congruent statement part because I want to make sure we get to the other notes. But we could use the side angle side as our reason for showing them to be congruent. All right, last one here. What would X have to equal to make the triangles congruent? So I see two angles that or two sides that are congruent, pairs of sides that are congruent. And the angle in between them over here is 4x plus 8, and over here is 5x minus 7. Now, if we assumed them to be congruent, then those two angles would have to be equal. All right? So if we assume them congruent, meaning they're equal, that means that we can set 4x plus 8 equal to 5x minus 7. Right? So this situation would have to be true for the triangles to be congruent. Now we can solve for x, and that will give us the value of x that makes this true. We're going to subtract 4x from both sides. 5x minus 4x is x. Add 7. 8 plus 7 is 15. So we get 15 equals x. That's what we're looking for. What would x have to equal? Well, if x equals 15, these two angles will be equal to one another. Right? Now, if we could figure that out, I think it's 68. 4 times 15 is 60 plus 8, 68. 5 times 15 is 75. 75 minus 7 is 68. All right. We're going to go ahead and move on to our last three postulates. We had side, side, side. Skipping over a couple of these slides because they're just review. Side, angle, side. Next one, angle, side, angle. So in this case, it's kind of the flip of side, angle, side. But angle, side, angle, you're given two angles that are two angle pairs congruent, and the side in between them is congruent. Right. Now it has to be this order in both. There's gonna be an example in a little bit where you've got like two angles on a side where one side, the side's in between on one triangle, but the side's outside the angles on the other triangle. It doesn't work like that. It has to be angle, side angle for both triangles. Okay. Here's an example where we can use angle, side angle. Got triangle JKL, where we got single angle, single hash, right angle, single angle, single hash, right angle. So JKL will be FED. By angle, side. There's an example with angle, side angle. Fourth one, angle, angle, side. Angle, angle, side. This is a situation where you have two angles, and in both triangles, the side that is congruent, right, is outside. Okay, it's not in between the two angles. Now, this one we got to be a little bit more careful. It's easy to see when you got two angles and the side directly in between them, right? But in this situation, you've got to make sure that it's the same order. This is where, when we were getting the congruent triangles and kind of sorting them yesterday, some of them didn't work. And it's because the order of the congruent parts was different. Like in these two triangles, it goes, a lot of times I go clockwise, or I go in the order that the postulate's written in. So angle, angle, side. So angle, angle, side, we go double, single, and then our side. So in this triangle, we have to go double, single, and then our congruent side. If for some reason the single hash was over here instead, okay, well, in this triangle, we went double, single, side, and this one, we went single, double, side. If this were the way I have it drawn on the right now, if that were true, these would not be congruent, or we couldn't use angle, angle, side to show they're congruent. Okay, it has to be the same order. All right. Tell us how you know the triangles are congruent and write a congruent statement. So we've got on the left-hand side, we've got these two right triangles. Okay. And looks like we got a right angle, single hash, single arc, and then a single hash. Right angle, single arc, single hash. So it looks like they're correct. Angle, angle, side. Looks like these both work. Let's write a congruent statement. Triangle, stay alphabetical, A, B, C. It's congruent to triangle. See, right angle. The next one's the single, so I gotta go TRS. By angle, angle, side. Okay. And B, so when we gotta do a little work here. So a shared side is congruent to itself. I don't see any angle pairs here, but I do see 3 pairs of sides. So I could say triangle. Let's do the top one. I'm gonna go in this order just because I see single and then double, so TQR is congruent to triangle. Let's go single double, so RST. By side, side, side. Again, we have to say the by part, like by this reason, when you're not given all 6 congruent parts. Tell how you know the triangles are congruent and write a congruent statement. So shared side is congruent. I'm actually not going to write out the congruent statement because I want to make sure we get through the rest of these notes. But I do see that we got the congruent side and we do have single side double, single side double. They are, we can use angle side angle. Okay, we can use angle side angle there. Prove the triangles are congruent. This is one we're going to need to come back to because we haven't learned this one yet, but it's the next thing we're learning as far as in like a couple slides. B, okay, B is one where we're using some previous knowledge to get our answer. It looks to me like we don't have enough information, or we have the wrong information, because it looks like we got angle side side, right? And nobody would ever name a postulate that, all right? So it doesn't exist. So that doesn't work. But what we know is these sides are congruent. And we learned in our last unit that angles across from the sides are also congruent. So if this side, if Q is a single arc, P would also be a single arc. We can do the same thing in our other triangle. If L is a single arc, so is M. Now we have enough information to use angle, angle, side. Because we have 2 angles and 2 sides, right? But it doesn't matter. 2 angles and 2 sides is enough. Okay, we really only need 3 of those things, the 2 angles and 1 side. But we can use angle, angle, side to prove these triangles are congruent. Okay. Again, we're going to come back to A. We may have another example, but I'll show you why. This is yes, this is congruent. All right, even though it is angle side side. All right, I said that doesn't exist, and it doesn't, but in this specific type of triangle, it does work. All right. Tell how you know the triangle is congruent and write a congruent statement. These are 2 examples that actually don't work. Okay, they don't work. There's no way to say these are congruent. And we talked about this example yesterday. This is actually like angle, 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 where you have 3 pairs of angles that are congruent, right? We could say not enough information or not congruent. And that's because we talked about this the other day. Those angles are still staying the same angle measure, right? But that triangle, as it gets bigger and smaller, is definitely not congruent to A, B, C. Okay. So even though the angles stay the same measure, right? When it can get bigger and smaller. Again, we call that similar. It's similar because its dimensions are all proportionate, but it's not congruent. And the one on the right, we do have 2 sides and an angle in both triangles, but that angle's in a different position, okay? It's between the sides in our first triangle, and it's outside the sides in our second one. They have to be in the same order for them to be used as congruents, right? So another one, not congruent or not enough information. Okay. Not saying, and again, not congruent is probably not exactly correct because there is a situation where they could be congruent still, but it's not enough information for us to prove that they are. Here's our last congruence postulate or theorem. Hypotenuse leg. This is the one situation where angle side side works. Okay? This is the one time that it works. And it works in right triangles. But we don't call it angle side side, we call it hypotenuse leg. If you are given in any right triangle the fact that the hypotenuse, the longest side, is congruent, you have that pair, in any leg, so the legs are the ones that come off of the right angle, these are congruent by hypotenuse leg. Now, the reason why this doesn't work in every triangle, okay, is because we could have a situation where we've got an angle that's congruent and two other sides congruent, but there's two ways we could draw those triangles, okay? I could draw the triangle where this is angled a lot closer, or I could swing this over this direction and draw it like this, okay? So having an angle and two sides isn't enough information to prove the triangles are congruent, right? Only in right triangles, okay? Only in right triangles does that work. And that's because those right triangles are just, they're rigid in those right angles. All right. So this is an example here. Okay. Let's make sure that these both work. I know the one on the left works for sure because I've got hypotenuse leg. My hypotenuse is a double and the leg is a single. So triangle, let's see, let's do WBU is congruent to triangle, see, it's single, so FED by hypotenuse leg. Okay. Now, the ones on the right, those look congruent, but there's a problem. Okay? And that problem is my hypotenuse down here is the double, but up here it's the single side. Now, first of all, I don't think it's physically possible to make them look like this, because if the double is bigger than the single, then it would have to be like that in this case, which isn't possible in a right triangle. But it's just another reason why these are not congruent. Okay, it's just not going to work. The sides don't match up the way they should. Okay. Now, if I had switched this and this was the double, and that was single, then yeah, it definitely would work. And we could say through hypotenuse leg that they are congruent. Okay, just going through these a little quicker. Here, these two, we can use side angle side. Right, we can use side angle side in A to prove they are congruent. And looks like they're just rotated to get one to the other. Over here, side angle side again. Shared side gives us that second pair of congruent sides with the fact that this goes straight it's a straight line. We have a 90-degree angle, we can determine that's also 90 degrees. So we got side angle side. This one, we got a shared side. Yep, another side angle side. All right, give one additional fact to prove the triangles are congruent by the theorem stated. So we want to prove that these are congruent using side angle side. So it looks like we're missing the angle. Now we got to be careful about which angle, but here's the one fact that we could prove. Now we can write it in, but I want you guys to write the fact down too. So that angle and that angle need to be congruent to use side angle side. So we would say angle J is congruent to angle F. That would be the one additional fact that we would need to prove the triangles are congruent. Give one additional fact to prove the triangles are congruent by the theorem stated. Angle, side, angle. Well, it looks like we've got the two angles. So I think we're missing the congruent side. Now, if we're doing angle, side, angle, we need the side to be between the two angles. So that side and this side. So we need to write that fact. So we'll say WB side WB is congruent to side. Now, you don't have to write it this way, but I went right angle single, so I'll do the same here, FE. But if you wrote EF, side WB is congruent to side EF, that'd be correct. It's the same segment, it's just a different way to name it. All right, so here's one where it says, it gives you a little bit more freedom. State one additional fact that's needed for the pair of triangles to be congruent. Then write out the congruent statement and the reason why the triangles are congruent. Now, there's actually two different correct answers here. Somebody want to tell me one additional fact that would work to prove they are congruent? Anybody see a place where we could add a fact? Yeah. Good. Yeah, we could say those angles are congruent, and then we could use side angle side. Right? Let's say that we're starting from scratch again. Does anybody see a different fact that would work? Yeah.
Wouldn't that be angle side?
It would be angle side. Thank you. Angle side.
To make it, you can.
No, I don't. Side angle side wouldn't work just because of where the initial angle is located, because it's not attached to that. If it was, we could use the other side. How about another fact that would work? I'll give you a hint. It'll be the same theorem, just a different angle. Yeah. Yeah, we could have done angle A is congruent to angle X. And we would have had angle side again. Yeah. But these would be angle side. Now sometimes you can use different facts and use different theorems. Like in this example, state one additional fact that is needed for the pair of triangles to be congruent. Like right now we have enough information to say that we basically have two sides. Like one additional fact could be like AC is perpendicular to BD. Okay, that could be a fact, and that gives us these two right angles, which we can use hypotenuse leg width then. Okay, so using this fact would lead to hypotenuse leg. Probably a little easier one might be angle BAC is congruent to angle DAC. And that would lead to side angle side. Another one you could do here would be BC. So this segment is congruent to DC. And that would let us use side, side, side. Okay, so there's actually, I see 3 different ways that we could add one fact. And that one fact would lead us towards 3 different congruence postulates. That might be it. Yeah. All right. That covers all of our notes that I needed you guys to get through 3.3B and 3.3C. So you guys can go ahead and put your notes away. On Monday, when we meet, we're going to go through the rest of that Desmos activity. And it's 32 slides, but I think it's going to be really important for us to go through those. Some of that will be self-paced, like I'll give you guys like 5 or 6 slides I want you to work on your own. And other parts I'm going to want to stop and go over together as a group. But I appreciate you staying with me. This was probably a little bit longer notes than we typically be going through in a day.
I think